Today's lesson is on asymptotes and rational functions. Part of this lesson is review from earlier this year, but there's some new information. So let's start with vertical asymptote. I'm going to just write a function, f of x equals 2x over x plus 3. So what part of this function creates a vertical asymptote? And that is the value of x that creates a 0 in the denominator. So in this case, x plus 3, we don't want to be 0. So what value creates the 0 is when x is negative 3. So a reminder, vertical asymptote would be, let's see, 1, 2, 3. At negative 3, it's that dotted line. So maybe a graph will look like this. Okay, horizontal asymptotes. I'm going to give two different functions. The first one, x to the third minus 1 over 2x to the fifth plus 7. So in this case, anytime the degree is, I was supposed to say big, larger in the denominator, smaller on top, the horizontal asymptote is y equals 0. So in that case, the horizontal asymptote y equals 0 is the x-axis. And then the other example, f of x equals, let's say, 3x squared plus 1 over 5x squared minus 2. When the degrees are the same, they're both 2, you're looking at the coefficients. The asymptote in this case would be y equals 3/5. So 3/5, that's just above 0. So horizontal asymptote right there. And the last type of asymptote is an oblique or slant asymptote, which we also call oblique asymptotes. Okay, so here is the example. X to the third plus 5 over 2x squared minus 1. So if you look at your degrees, it is larger on top than it is on the bottom, but the special case is that it's exactly 1 more. So if you're looking at 3 and 2, the top is larger, and 3 minus 1 is the 2. So that is what creates a slant asymptote. So I'm going to draw just a example here. It's not this exact graph necessarily, but just what a slant asymptote looks like. So we could have something like this. So like I said, I'm not necessarily graphing that function, but just so you have a visual of what an oblique asymptote looks like. So we're going to do two examples where we find the different asymptotes and then use like graphing calculator or Desmos to just help us sketch a graph. Okay, so first we're looking at vertical asymptote, and that is looking at the denominator. So that denominator, x squared minus 9, we want to know when is it going to be 0, because that's where we have vertical asymptote. This can be factored to x plus 3, x minus 3. So therefore, we'll have vertical asymptote at x equals 3 and x equals negative 3. So I'm going to draw those on the graph right away. So dotted line at 3 and negative 3. All right, now looking at, do we have any horizontal asymptotes? So the degree is the same. So coefficient is where we have a horizontal asymptote. So that would be at y equals 3. So lots of 3's going on in this one. So there's a horizontal line at 3. And now slant asymptote. In this case, there is no slant asymptote because 2 and 2 We can only get a slant asymptote if the numerator degree is 1 higher than the denominator degree. So there's none here. And then for this lesson, we can just use graphing calculators or Desmos to help us just sketch a graph. So I used my graphing calculator, and then I got some points and then was able to sketch this graph. Okay, example number 2, h of x equals x squared plus 3x minus 3 over x plus 4. So let's look at one thing at a time. Vertical asymptote, that's our denominator. X plus 4 equals 0, so x equals -4. So we've got a vertical asymptote. I'm going to put it on the graph right away at -4. So for horizontal asymptote, I'm looking, the degree is higher than it is in the numerator that is in the denominator, so there is no horizontal asymptote. But notice how the degree is x squared in the numerator and it's just x in the denominator. So because 2 minus 1 is 1, there will be a slant asymptote. And here's how we find it. We have to do some long division. So I'm going to do x squared plus 3x minus 3, and I'm going to divide it by x plus 4. So looking at the leading terms, I'm going to have x, so then x squared plus 4x, subtract. -1x, bring down -3. And then I'll have -1 up here, which will give me -1x minus 4, subtract, and I'll have 1. So I have a remainder. The remainder does not matter, it's this. So even when we have a remainder, we can just ignore that. And this right here, y equals x minus 1, is the slant asymptote. So that is a linear line with y-intercept -1, and the slope is up 1 over 1. So I will draw that. So I used my graphing calculator to plug it in, and I got some key points, and I kind of saw where the graph goes, and I graphed it. So there is your full lesson on asymptotes and rational functions. Good luck.